Thank you all so much for coming. Let's give a big round of applause for Jackson and Cyril and everybody at AIUG too. These events are really awesome. I love them so much. Been to quite a few of these before, including their big conference in January, and I've just learned a lot. And I'm very excited to be on this side of the table finally, and hopefully giving something back to all of y'all. So this is my talk. It's called Backwards RAG, Building a GAR App. I actually just changed the title last minute, but here we go. A little bit about me before we get started. My name is Nick Battjes, as we covered. I'm the co-founder and CTO of Valquery. My other co-founder and best friend since middle school is Pete. He's in the audience there. Pete, give a wave. There he is. You can go talk to him during networking time. Before we started this company, I had spent my whole career in e-commerce, mostly working on Salesforce Commerce Cloud. And then towards the end, I actually got into a niche moving people off of Commerce Cloud onto more modern composable headless architectures, mostly doing the Next.js like front-end parts of that. And that was what ultimately gave me the skill set we needed to do Valquery. Couple of fun facts. I like Dango a lot, those dumplings that I'm eating in the picture there. I know several things about analytics now, having been in space for almost a year, but definitely go to Pete with those questions before you come to me. And I used to host video game pub trivia nights. So if you have any interest in giving me a venue to do that, I have about 400 slides of video game trivia kicking around. Especially if you're willing to pay me to do it, then let's talk during networking time. I think we can work something out. All right, that's enough about me. Let's talk about RAG. So we won't spend too much time on RAG because most of you, I imagine, have been to one of these events before, and you have heard probably 17 different explanations of how RAG works. It makes me cringe every time I hear the name too, because it makes me think about RAGs. I will quickly go over it just in case we have any people who are new to RAG. It's short for Retrieval Augmented Generation. It's basically a process by which you can use a corpus of some specific information to improve the quality of LLM results. It's got two parts. It's got an intake flow. You have some sort of data sources. You get sweet data out of those through some sort of data process, which converts it into chunks of sort of short, cogent natural language, which you can then run through an embedding model and generate embeddings off of, and then store in a vector database. So that when a user has a query, goes through your front end, that query can go through the same embedding model, get converted into vectors, and those can be used to do a vector search against your corpus, and then return some relevant results, which will go to the LLM along with the query and be used to hopefully improve the quality of the response that the LLM generates and then sends back to the user. I put text in there. Of course, we live in a multimodal world now, so it could be video, it could be a picture of a scary cat, it could be whatever. That's enough about RAG. We're here to talk about GAR. So the story of GAR, I struggled for a long time to really come up with a good technical summary of what Valquery does. I learned the term RAG while we had already been working on it for a while, and I knew that wasn't it, but it was close. And it was actually at AIUG conference in January. I was just in the lounge upstairs kind of ruminating, and it came to me. It's not RAG, it's GAR, which I messaged Pete after I found out the name. I was very excited, and he was like, "You mean this little fish?" And I was like, "No, it turns out there is a freshwater fish native to North America with poisonous roe that is also called the GAR. So don't eat their eggs." But let's talk about what GAR is in our context here. Generation Augmented Retrieval. It's very similar to RAG. It actually includes every element from the original graphic. There's just a couple extra things at the end. All of the data intake is the same, except that when the user gets all the way through their query going to the vector database and then into the LLM, we ask the LLM, is this information enough information to come up with a good answer to their query? If it is, we send the search results and the generative response right on back. If it's not, we get a follow-up question and go back into the database and get more search results and go round and round until we have enough to answer the question. So we're asking the LLM to rely on the search results to answer the question rather than relying on its sort of inherent capabilities, because the point here is really not to deliver an LLM response, or it's not to use search to improve an LLM response. It's to use an LLM response to improve search. Thus, generation augmented retrieval. I always say assisted for some reason, instead of retrieval augmented generation. Now, why do we need to do this? Let's talk about Valquery. So the jumping off point for Valquery was that Pete, who has spent his whole career, or most of his career in data analytics, came to me and said, fundamentally, data warehouses have too much data. So we can't find anything in the data warehouse. Every time we go to answer a question, we go root around through the thousands of tables trying to find which of the 17 orders tables is the one we need to answer our question about orders. And ultimately, we can't find exactly what we need. So we make another orders table that does do exactly what we need. And every time we do that, we've made the problem worse. And what about documentation? You may say, this is a room full of developers. What's the first thing you stop doing once you start getting busy at work? Writing documentation. Yes, there we go. You probably won't start again until you've already put in your 2 weeks notice so you don't have any more tickets. At least that's how it went for me at my last job. So how are we going to solve this problem? And, even if you are doing good documentation, you're spending a lot of time writing that documentation that could be spent doing things that have a much higher ROI. So we had a sort of realization that technical teams, including analytics teams, generate so much text about the work that they're doing while they're just doing their work. Not while they're doing bespoke documentation. They write tickets. They make comments in code. They do, in fact, write documentation, and why wouldn't we harness it? They chat with each other on Slack. This is all natural language text that's about the data resources that they need to answer their questions. So we thought, what if we could figure out a way to harness all of that just already existing ambient contextual information to enable people to search for data resources to answer their questions. I promise there's only one more slide, then we're going to go to the actual demo. So I just wanted to get this part out first. It was really the important part. So we pretty quickly came upon two fundamental elements that came to define Valquery: references and results. References are those little pieces of contextual data, such as code comments, PR discussions, tickets, documentation, that we will be doing our search against. And then results are resources in the data warehouse that are what the analyst is actually looking for. So the problem we had to solve was, how do you search against the one on the left and find the one on the right? And that's what we'll talk about now. So enough of slides. Let's go over to Valquery. Let's go ahead and put in a query. So as you can see, the UI is pretty simple. It's an iceberg product. There's a tiny front end and a great big back end. I actually just realized this today. The UI kind of looks like an iceberg too. There's like a little bit of white on the top and then a big blue ocean below. That was not on purpose, but it works out. All right, so let's just start with, these are our search suggestions that Pete very much came up with. I had been asking it like existential things about the nature of God or whatever, and that he came up with good analytics questions. So let's try, what is our average contract value? Now, this is going to take a minute because there's quite a bit happening here. We have to do potentially multiple loops of doing vector search, having OpenAI, we use ChatGPT 3.5 Turbo to come up with responses, and then also talking to Snowflake. But at the end, here we go. We've got, this is the cumulative response that sort of explains how you can use all of the results together to answer your question. And these are the results. So we're going to talk through the anatomy of a result real quick. So we have a resource identifier, database schema table. This is the actual data resource, or these are the actual data resources that will hopefully answer your question. We can pop down and see a little bit of sample data here. I actually wound up having to use, I used OpenAI to generate the column names, and then had to do just like some bespoke proc gen for the values, because OpenAI just refused to put in the right SQL data formats in the rows. I spent like 2 days on it before I gave up and just wrote my own proc gen. So that's why we have lorem ipsum for these. So yeah, that sample data is also going to be used in the follow-up flow And in the explain button, which we've got over here, which will give you a more detailed, you see it messed up the spacing. Which will give you a more detailed explanation of how you can use just that table to answer your question. And it also enabled me to keep this thing a little shorter, because if you want more detailed information, you can just drill down into this thing. Because once I made this have a lot of tokens, it slowed down quite a bit. Actually, funny story, until I think December or January, this was the whole app. It would just be 2 results and the explain button, and that was it. And then Pete was really the one who had the epiphany where he's like, that led to GAR, where it was like, okay, why don't we use the LLM to improve the search results and have it come up with follow-up questions and decide when there's enough results. And that was really what kicked this thing into high gear, I feel like. So last thing we've got here is, of course, references. They, in our context, really come in 2 flavors. There's either Git or Notion references. We had plans of building out many, many more. There's obviously dozens and dozens of places you could potentially get these. There's your Jira, your Confluence, your Slack, your Teams, your Bitbucket. Does anyone use Bitbucket? Any Bitbucket fans in the house? We got literally one big advantage of that tech. I had to use it at a client for a while. So yeah, let's drill into what these references look like. So we're going to pop over to our logs here. All right, beautiful. This, I imagine, is pretty hard to read. Can you guys see this? Okay, let's try to make it a little bigger. So let's go ahead and drill into one of these. I have my saved queries over here. Let's pick a table. Let's start with the Git results, or Git references, because they're a little easier to talk through. So let's get bear with me. I'll let this in. Marked available to renew. Marked. So these are all of the references to that. So let's go ahead and find. This is actually more of them than I thought there. Okay, yeah, let's filter by source. All right, so here we can see what we're actually dealing with here. We decided not to surface the content of the references pretty early on for a couple of reasons. We thought it'd be data overload, first of all. Like, you're going to be reading through all these little snippets. You don't really care what the snippets are. You care what the results are. So, and it would look kind of gross in the UI. Also, we thought there would be some sticky implications when we got into the chat part of it. You could be surfacing chat messages from executives that they might not want you to see. Who knows what the vector search is going to think is related? There could be unsavory things. Who knows? Once you get into chat, it all gets messy. That's why we haven't done chat yet. But anyway, let's go ahead and see where this comes from. So this is going to be union of all charges, and it's going to be in Mart available to renew. So is anyone here familiar with DBT? So DBT was really the jumping off point for this whole project. It's a very cool, it's a basically the transform part of an ETL as code. So you have a repository that defines each view as a SQL file, and then you can run that periodically, either from the CLI or they have a cloud offering as well. And it will just go through your whole DAG and regenerate everything based on that repo. And what that enabled us to do also was, this is snapshots. I need, where's the, oh, yeah, big shout out to GitLab. We could not have done this project without GitLab, because GitLab was awesome and made their whole very mature DBT repo available under the MIT license. So we were just able to develop against that. And their documentation hub for their analytics team is also public. So it was really invaluable for us because we very early on realized that even with LLM tools, it's nigh on impossible to not just generate a replica of like a mature company's data warehouse, but to generate a years long history of conversations about that data warehouse across multiple tools. We tried and it didn't work. So this was really invaluable to us. Big shout out to GitLab. Give them a round of applause. Beautiful tool. I actually like it more than GitHub now. I had never used it before this, but their API limits are much more generous. I had to put in a queue system just because GitHub was so stingy with me when I was trying to pull data from it. Anyway, so the way dbt works, we basically know that anything that's related to this mart available to renew file is going to be related to the mart available to renew table in Snowflake, which is nice because if we look through here, I'm sure we'll find union of all the charges. This is a comment, right? Yes, we see it's the type comment. So if we look in here, there it is. So this was the comment that was used as a reference to point to this table. And obviously, any one of these references can be pretty esoteric. So what we actually do is we get back 100 or 1,000 of these references. I've changed it back and forth a few times. I can't remember what it's at now. And then we store on the references what tables they're associated with in the Pinecone metadata, so that then we can process all of the references, figure out which results have the highest counts, and then those are the ones that we've decided are the best and the ones we return. And like I said, it's really clean with GitHub, but with Git, because we have this one-to-one relationship. If we go look at one for Notion, it's going to be substantially more gross in a way. Let's look at Notion. So yeah. Oh, sorry. Yeah, I'll step back and talk about Notion. So Notion is a sort of alternative to the Atlassian suite, I would say. It's like Jira Confluence. It is one tool that is both a ticketing system and a documentation hub. It's really just like a free form wiki almost. And the way it's structured is a little different too. It's much more regimented than any of those. Like I actually have it open over here. We can take a quick look. So this is a typical Notion sort of page. You can see every time I mouse down this column here, there's a little thing next to like either the LI or the paragraph or the heading or whatever. It's because every entity on the page is its own like discrete chunk. So when you query their APIs, they return each of these things as a separate item. Like it won't just return you the page, it'll return you all of the blocks on the page, which is interesting and actually both helpful and not helpful for chunking. Sometimes it's good, sometimes it's catastrophic. But anyway, so you can see with these, we wind up with lots and lots of results off of one reference. And that's because when we got to doing open text rather than the nicely structured Git stuff, I pretty quickly realized that the references can be very far away from the results on the page. Like they could be very close or they could be very far. And because you're dealing with blocks, it could be like 5 blocks away. It could be 50 blocks away. And it could still be relevant. So we ultimately decided to go with every reference on a page is relevant to every table on that page, which is kind of a lot, but it improved the quality of our results enough, just having Notion there, that I never really saw a reason to change it. After that, I am running out of time. All right. Let's just speed run through looking at a follow-up question. We decided not to surface the follow-up questions either, because ultimately what you're looking for is results. We don't really want to show you the nuts and bolts of what's going on too much. Let's get my follow-up question query. So you can see here, these are some follow-up questions that it's come up with. Like this was, what is the total amount of all charges and the total of all the total number of charges in the FCT charge table? Somewhat relevant question about this data. And then that caused it to return some more of the results that we saw over here. And then ultimately, when it's done enough loops and the LLM is like, okay, this is some good stuff, we're ready to go, it'll just say no follow-up question. And that is what lets the app know to shut it down and start sending responses to the user. So yeah, ultimately that's how it works. I mean, most of the real cool stuff happens in the data ingestion flow in that little sort of chat circle. But I'm not going to show you the prompts because I have to keep some mystery preserved, right? But yeah, ultimately that is Valquery. I've just got one more slide here. I'll spare you the graph since we just showed you how Valquery works. Let's talk a little about where we are now. So we actually decided to open source Valquery earlier this year. So at the end of February, Open Valquery was born. If you want to scan the QR code, you can go get it and you can run it locally and do whatever the heck you want with it. It's on a very permissive license. We think there's a lot of use cases for it beyond data analytics too. We can expand it to business intelligence tools, would be a natural fit. Incident forensics has also been brought to my attention as a really good fit. You could sort of comb through your suite and sort of figure out maybe where a problem originated based on people's conversations. If anybody wants to build that out, I'd love to see it. And yeah, we have more or less paused active development on it ourselves for fiscal reasons. So if you want to track me down on LinkedIn, I am readily available. And that's been my talk. Any questions? We have a prompt that basically asks, we continually will add the new information that it's gotten to the prompts and basically just ask it to be like, okay, we have a prompt that basically preps it for its role. And then we say based on this role and this data and this question, do you think you have enough information to formulate a good answer? And they're smart enough to most of the time figure it out. Yeah, we didn't decide to update it to GPT-4 because this is faster and our responses are already pretty slow and they were good enough. So we stuck with it. That was sort of now that we had the fundamental flow down, sort of the next thing was to build out more and more integrations, because obviously the data analytics space is pretty fragmented in terms of what exact productivity stacks people use. That's something I'm hoping the open source community can pick up the slack on. If I was going to do it myself, I would probably pivot to using Meltano. If you're familiar with that, it's a really easy way of just pulling tons of data from tons of different sources with Python. I didn't use any Python for this project because I sort of am a masochist and decided I wanted to do it with all Node, but I would do that differently going back. Yeah. Sorry, what was the follow-up? Okay. The follow-up question was similar. Yeah. So obviously, ideally this would be almost Zapier level of integrations. So ideally, we're only getting back files that are relevant, because these are the files that we've used our aggregation to decide are the most relevant. The only time we actually discard files is when we decide that they're invalid for some reason, like if they don't have data in them or if they don't exist. We do some checks like that, but that's really what the search and the LLM are there for, is to decide they're deciding that these files are relevant. Like I said, when we started this project, I was pretty new to analytics, but my impression was that Snowflake is sort of the big player in the space right now. It seems like the most popular choice. So that was why we went with it, ultimately.